now we have gone through the understanding data, import and inspect data with info, shape, head, describe, and other things. Okay, and missing data analysis we have already done, detect and handle. And if you see last week, we are, yeah, I think we have done this also, data type and consistency check. Okay, ensure clean data. Okay, the objective is to have a clean. If you have any unformatted data uh, like a categorical data or object data, which you need to convert, you can use the convert. You can convert those data to uh, do your analysis, because Python understand numerical data. Okay, it doesn't understand categorical or object data. Okay, it will not compile those. So today's topic is on descriptive statistics. So we're gonna learn what is descriptive statistics, summarize numerical, categorical, understand mean, mode, median, standard, and frequency distribution. Uh, okay, so this is the file in Jupyter Notebook I have created. Okay, just the theory. 5-10 minutes we'll spend some time to understand descriptive statistics. Okay, how it will be very useful for analyzing your data. Okay, so after the class is done, I'll share this file with you guys. Okay, so what is descriptive statistics? Okay, what does it do? It helps you summarize and understand the main feature, okay, of a data set, both numerical and categorical. Okay, so whatever the data you have, before you perform any deeper analysis or modeling or send it to the next level, which is machine learning. Okay, so if you can do deep understanding, analysis on your data using descriptive statistics. So in statistics we have descriptive, prescriptive, right? We have already seen in our statistics call in the previous session when we are doing the basics, right? So, so this is one of the descriptive statistics we perform on data. Okay, so what it answers descriptive. Okay, how does the data look like? Okay, how is it distributed? If you remember the bell curve, right? So if your data is forming a bell curve, okay, when you create the visualization, right? If it is in a bell curve, then we say the data is symmetric. Okay, it's properly distributed. If it is left skew, right skew, right, that is where you have to work on your data, all those data points, and then you have to fix it. Okay, so another thing that we have to see, are there any patterns, okay, anomalies and or outliers. Outliers is, we'll see shortly. Okay, what is outliers? Okay, why it matters is summarization. Okay, and what does it help you? Help you describe large data, okay, with few numbers, mean, median. Okay, if you have 10,000 rows and if you want to see what is the mean and median, you have to, if you go with the traditional method, you have to, in Excel, you have to do a lot of work, right? Here, you have to just write one line of code that will take care of the entire analysis for your data. Okay, and why data cleaning is important is it identifies missing, wrong, extreme values. Okay, if there is a age group of students in class 10th, okay, generally you will have a age group of uh, uh, 14 to 15 years, right? What if you have 21 years, 30 years? Okay, so those are all called outliers in the age group. Okay, so you need to clean that. See, it could be a mistake, or if the data is given by the stakeholder, you have to go back and ask them, was this data correct, or it was by mistake. Okay, so 30 cannot be there, right? If you have 30 and when you do the analysis average, it will differ. Okay, and when you take the decision making, what happens? It will not work out. So feature understanding, okay, show data spread, variability, and distribution. Okay, and likely and finally decision making. Okay, so it guides assumption for modeling, forecasting, and hypothesis testing. Okay, all this we will see in the advanced level of Python, where we will learn supervised, unsupervised, reinforcement learning, and all that. Okay, so what are the type? Okay, so we have central tendency, dispersion, spread. Okay, dispersion is nothing but the spreading. How is your data spread? Okay, same bell curve. Okay, categorical summary. Okay, frequency of categorical. How many are repeated there? Okay, so you will use a count method. Okay, like value count and percentage. Okay, central tendency, mean, mode, median, and dispersion is range. What is the range of my data? Variance. Okay, how much it differ from my actual mean. Okay, standard deviation. Okay, and IQR. If you remember the box plot, right? We learned about the IQR. Okay, interquartile range. What we'll do is we will take some sample data. 1 minute. Okay, I'll just copy this only. Okay, for practice. Okay, so I have this data. So what type of data is it? Dictionary. Okay, name, gender, marks, and study, some sample number, and then I am converting that whatever data you see dictionary in the form of data frame. Okay, like a rows and columns. Let me print the data and let me see. Okay, so we have 4 columns and we have 6 entries and what else? 4 columns, yeah. And you can see 2 columns are object, which is categorical data, this and this, and rest are integer. Okay, we'll see our data. Okay, so these are data. Okay, looks good. So let's start our uh, first thing is what we'll do is central tendency. Okay. Okay, so what I'll do is I'll write simple command print and I'll write in quotation mean. Okay, mean comma df. Okay, so df which columns I want to give numeric, right? I cannot give categorical for the average, so I have to give the name of the column which is numerics, which are those marks. Okay, and also check the heading, label heading. Okay, if it M is capital, you have to write in capital. Okay, and I'll use something called uh, mean. Yeah, this is the one, mean. Okay, so same thing. I'll just copy 3 times. One is for uh, 1 minute again. There is some problem with the indentation. Uh, Okay, I'll write down here no issues. Okay, so next one is median. Okay, so here also I'll change the label median, and third one is mean, mode, median. Okay, mode. What is the mode here? So I'll change the function as mode. Okay, I'll run this and then we'll see the results. It says incomplete input. Okay, bracket I didn't close. Sorry, guys. Okay, here also I have to close the bracket braces. Okay, so first one is main is 87.5. Okay, the average. And what is the median? 89. Okay, 89 is the midpoint for these values, which is a median. And what is the mode? Mode is a repeated value. Okay, so there are none. Okay, so all are unique. So it says 0. Okay, so it says 0. Okay, so this is the first. Okay, now we'll see the dispersion. Dispersion is spread of your data. How your data is spread. Okay, same thing I'll copy. Okay, I don't want to type 1, 2, 3. Okay, so first one is I'll use something called variance. Okay, I'll take the marks and instead of mean, I will use something called variance function. Okay, second one, I will use standard deviation. For standard deviation, you have to use STD. Okay, and here you have to change standard deviation. Okay, for marks only we are doing this. Why? Because it will work only on numeric value. Okay, and the last one is range. What is the range formula? Range is max minus low. Okay, so I have df marks. I'll say df dot max. Okay, this is the function I'm using max. Again, I'll say minus. I will use the same thing. I have to use min. Okay, max minus minimum number. So you'll get a range. Okay, df marks dot min function. Yep, that's it. Let me run it. Okay, so the variance is 49.1 variation. Okay, and the standard deviation of 7. Okay, so what does this mean is whatever the mean we got here 87. Okay, so whatever the numbers you see 85, 88 here 88, 92. Okay, there is a difference of 7 points. Okay, or a deviation, standard deviation. That is what we say. If it is huge, so that means there is some problem. Okay, it should be less. If you see the number here 88, 92, 75, 85, 90. Okay, if you have 200, 300, then you will get a standard deviation of 20, 30, which is incorrect. Okay, that is how you're going to see how my data is dispersed. And range is 20. Okay, so the range is 20 difference altogether. Max number minus low number 20. Okay, clear guys? Yes, no?
Yes, Suren.
Give me one moment here. Okay. Now what we'll do is we will check at the categorical summary. Okay, categorical is very important. Okay, so I'll write print df. Okay, which column I'll take here? Okay, I'll take gender. Okay, I want to count. I'll take gender, close, then dot. We have a function called value counts. Okay, you can use it for categorical data. Okay, so we get a clear picture here, gender, title, and we see male, female are 3 3. Okay, so we have a equal distribution. Okay, and we can do the generic, the other command, which is df.describe also. Okay, but it will give only for numeric data. Okay, so the count is 6, mean is 87, 6.5 study hours. Okay, standard deviation is 7 and 1.8. So from differ from one another is 1.1 hour 8 minutes, something like that. Okay, minimum number is minimum hours for study hours are 4 and max is 9 hours. Okay, and 25th percentile, you can see 5 is 5 people out of 6 people, 2 falls under this, 2 falls under 6 hours, and 2 falls under 7 hours, because we have only 6 entries in our sample data. Okay, and this is the maximum. 95 is the maximum, minimum is 75, and 25 percentile is 85, 90, 89, and 91. Clear? And how do you interpret this? Okay, average marks is equal to 87 point, uh, average is 87.5. Okay, middle 50 percentage IQ lies between 85 to 92. 85 to 92. Okay, and variation is 7.26. What that means is data is moderately spread. Okay, so you don't see any skews there much. Okay, and whenever you want to include the objects, okay, whenever you want to include the objects, okay, what that means is whatever the objects, what it will do is it will pick up the categorical data as well. Okay, so you can say df.describe. Inside that you have to say include equal to all. Okay, or you can also say only object you need, then you have to say explicitly objects. Okay, let me run this. Data type objects not understood. Okay, maybe I think I have to use all. 1 minute. Cannot interpret built-in function all as a data type. Include is equal to, okay, you have to put it in quotes. Simple. Okay, now you see I'm getting all 4 columns. Okay, so gender, gender is a categorical data. You see male and female. Okay, now you see nan. Okay, not a number, so that's okay. But if you want to calculate, or if you want to see the summary of all columns, you can use this include is equal to all, which will pick your categorical data as well. Okay, so this is one, uh, but why this command was not working. Object, yeah, now it is working. See, same thing I included last objects. Maybe objects I typed last time. 1 minute. Yeah, objects. Objects. There is no parametrical object. It is objects. Object. Okay. Now I'm getting name and gender. Okay, name and gender, which are like categorical data. So how many count? Six. Six. Unique. Six. Okay, and two are unique because we have male, female. Okay, top. Who is a top here? Amit, male. Frequency 1 and 3. Okay. This way you can do some analysis on your data as well. And if this is not done properly, what is the outcome you're going to see is if you ignore the outliers, okay, not checking standard or variation, okay. So impact, what is impact if you don't do the outliers is a misleading average. Okay, example income, sales, it will definitely mislead. Okay, and if you don't do a standard or variation or dispersion of your data, okay, what you're going to miss is miss the spread or yeah, spread, misspread. You will see the data misspread. Okay, and what happens if you ignore the categorical data summary? Okay, miss the key trends in behavior like gender. Okay, here, and if the data is not summarized before we are running our models, what happens is it will definitely get a wrong assumption. Okay, or I can say in simple language, poor prediction. Okay. Okay, now what we'll do is we will also see some visualization based on this data. Okay, so we'll just plot one or two category and we'll see visualization support. Okay, I'll import Seaborn as SNS, import matplotlib dot pyplot as plt. Okay, and then what I want to do is I want a histogram plot. Okay, so what I'll do is I'll use SNS dot uh, hist. I'll just type the hist plot. Yeah, hist plot, and I'll open the bracket inside. Which column I need histogram? I'll say df marks. Df marks. Okay, then I'll put a comma. KD is equal to true. Equals true. I'll say plt dot show. If you want to do a title, you can use plt dot title. Okay, you can give a meaningful title. So marks, right? Marks is plots. Okay, something like that. Let me run this. So right now it is busy, my kernel, 11 seconds. Yeah, now you see I have a beautiful hist plot. Okay, so if you see I have 6 data points. Okay, it starts from 75. If I see the original data, okay, it starts from 75, then uh, 85, 88, like that it is going. You can see here 88. Okay, so 85 is there, 88. Then these are the all data points. Okay, now you see the bell curve is going like this. Okay, it's not symmetric. Okay, something like this it should be. It is not. Now I doubt. Let's do a box plot. I'll say SNS dot box, not box in, box. Okay, box plot. So box plot is different. Okay, you have to pass with x and y value. So x is equal to, I'll say, gender. Okay, comma, y equals marks. Okay, comma. Now I have to point my data. Data is equal to df, data frame. Okay, and then I have to say sns dot show. Okay, to show display my uh, visualization. Okay, I'll run this. Okay, now you see what it says. Module has no. Okay, sorry, not SNS, PLT, matplotlib, PLT dot show. Okay, now you see. Okay, now this line that you see, it should be at the center. Okay, it is going towards higher side, and you can see there are no outliers. If you see any dots here after this whisker and this whisker, this whisker, this whisker, so we don't have any outliers, but we can see the data is going on the extreme side. And if you want to see the quartile range IQR, okay, so you can also say df dot quantile. Okay, inside you can say so 0.75 minus df dot quantile, df dot quantile 0.25. Okay, now why we are taking 0.25 and 75? If you see here in statistics, okay, so it starts from 0.25, which is 25% to 75%. Your data should spread between, this is 25, this is 75, this line. Okay, but you see your range is coming somewhere here. Okay, so that is what we are trying to find out. So we got an error. Let me check. Unsupported operand for string and string. Okay. 1 minute. What is this? This is gender. This is gender. Marks. Okay. Let me do it for marks. df. Okay. Same thing. I'll do it here also. Okay. 5.75 for marks. So you can see here, one of them is this is the marks. Okay, now you see here there is a difference and there is a difference here, female. Okay, and you see this, if it is center means, if it is at the center, this line that you see uh, between this whisker and this whisker. Okay, if this line is there, then we say equal. Okay, but here if you see by seeing this data, female are scoring more than male. I can say that. Okay, not about this line. Okay, it should be somewhere here, median. Okay, and this value count is very important, guys. Okay, you can use value count, something like this also. Okay, so male marks 6 hours, 1 1. So what does that one means? Only one entry. Okay, so data is unique. You are getting a count here, this one. Okay, if I add Amit 2 means you will see 2. Okay, this is a small data set. That is the reason. Okay, so this is a small data set that I took as an example for our experiment here. Okay, so these are very important, guys. Okay, so descriptive statistics, as I said, is one of the part of your EDA. Okay, exploratory data analysis, and this is very what do you call uh, very crucial. Okay, for to do your data. Okay, and if you want to see these cues, yeah, I forgot these cues. DF will take marks dot skew s k. Okay, so if you see the marks, okay, minus 1. Why? 75, 95. Okay, so data is looking good. Okay, so float value we are getting 1 point minus 1.25. Okay, we have kurtosis also. Okay, 1 minute, I'll take another sample example here. 1 minute, I have written somewhere in my notepad. Okay, I'll take this example. Okay, only one column which is marks. Okay, I have some number, marks number. Okay, and I'm converting that into a data frame. Okay, and then I'm printing my data frame. Okay, so this is my data frame, single column. Okay, some numbers. Now I'll perform all those in one shot. Okay, I have already written it here. These are all one line. Okay, same thing. df marks dot mean, df marks dot median mode, then standard deviation, variance, min, max, quartile. Whatever you do in describe, you can do it separately also. Okay, so mean is 86, median is 88, 76, standard deviation is 6, variance is 37. Okay, min number is 76 and max is 95. Quintile, you can see here 25%, 84 marks is falling under 25% bucket. 50% of them scored 88 and 75%, 75, sorry, 90 percent falls under 70. So 75 and above, all the students are have scored 90.75 marks. Okay, and skewness is minus 71, which is good. Kurtosis is minus point, yeah, point 0 minus point 3. Okay, It should not go on the plus or minus. Okay, it should be at the this thing. Okay, and you can see how do you infer by seeing this. The average marks is 88. Okay, I can say the average marks is 88. You can see 50% 88. Low standard deviation. Students have a similar performance, I can say, and I can see slightly positive skew. Few students scored higher marks. Okay, so I have one more categorical data. For example, these are all very simple. Okay, same thing I copied from the same example. I just kept it ready. So what I'm doing is I have a gender column. These are categorical data. I'm just converting that into a data frame and storing, and then I'm performing this value count. First, I'm going to check how many values are there. 1, 2, 3, 4, 5, 6, 7. Okay, and then I'll say normalize is equal to true, and then df gender mode is equal to 0. Mode I'm going to see how many are repeated. Okay, what is the mode for gender, categorical and unique values? Okay, and unique also you can use, which we have already learned in the basics. Okay, male is equal to 4. If you see here, 1, 2, 3, 4. So female 3 counts. Okay, and the type is integer type count. Okay, gender male female, this is the percentage. 42% are female and 57 are male. Name proportion. Okay, so this one mode is equal to male. Okay, if you see how many times mode repeated, 1, 2, 3, for female 3. So mode means the value repeated multiple times, you can pick this number. Okay, so male are the winners here. Okay, and then unique values are 2. Okay, so 2 are unique value, female female, nothing else is there. If I add transgender or others, you will see third one. Okay, I'll put a comma here, others. Okay, now you see unique value is 3. Three unique values are there. Okay, now you see others 0.1% because just one entry, so 0.1%. Okay, so this is very important, guys. These commands, right, simple commands, right, it will give you a good inference about your data. Okay, and you can do the describe method also. Df dot cri describe, same thing. With one command you can do discount, unique, top and frequency. Okay, but here it will not do the other, like n unique, yeah, n unique is frequency 4, unique is 3. Yeah, we are getting that, but you're not getting the mode and other things, right? So see, sometimes you have to use these commands to get the output. Sometimes you will get what is required from the describe method. Okay, so what we'll do is today we'll do the summary learning summary. So what did we learn today? Identifies data quality issue like missing value, outliers. Okay, with a box plot. Okay, and you can use the n unique also, or you can use the is null also. Okay, but in this case we don't have any missing. We have already done the first chapter. Now we are at the fourth chapter. Okay, now why descriptive statistics is important? What does it do? It helps understand data distribution and relationship. Okay, and it aids in feature engineering decision. Okay, and simplifies communication to the of results to other stakeholders whenever you want to explain all those things. So we have also seen visual summary. Uh, One is box plot and other one is hist plot. Okay. So these are all very important, guys. Okay. So just add it here. Okay, same thing. Shape, info, describe, mean, median, standard deviation, count, mode, haste, box plot, draw insights. Okay. Central tendency, we have seen central tendency is nothing but mean, mode, median. Dispersion is spread, or dispersion means your variance and range, and frequency is how many times it is repeated. Okay, these are all some good information that we can understand. Any questions, guys, so far, or are we good? No questions. Okay. Okay. I have another sample data. 1 minute. Okay. So I have this sample data. Okay. So this for your practice. I just created and kept it so that you can practice. Okay. Now what I want is you have to apply all these commands at the bottom, and you need to understand. Okay. So if I say df, how many? 19 rows. Okay. So I have added something called codes. AI, some random marks, steady hours, age, uh, gender, name. Okay. If I take the same command, okay. So what does it mean? 86. Okay. So whatever the scores that you see here, 86 is what is the average. Median is 86, 80 mode is 82. So 82 is repeated multiple time, I guess. 82, 82. Okay, you can see two times it is repeated. So mode means mode function will identify how many times a number is repeated. Okay, standard deviation is 5.7, 33 is the variance, and 77 is minimum, and max is 96. Okay, in 25% bucket, 81.75 numbers marks are falling. Okay, this marks 25% of the students have secured 81.75 score. 50% have 86 and 75% 90 and above. Okay, this is the skewness. You can see there is no minus. Okay, so if you see our skew for the previous one, it is going towards right. Okay, you see it is going towards right. What this means, it is going on negative. What if the this uh, line that you see, if it is something like this and this, it is on the plus side. Okay, so right side, this is called right skew, left skew. Okay, when we do this advanced statistics or machine learning, right, we have to revisit on all these topics. Okay, these are very important, guys, very important. Okay, so you can do the describe also. Df dot describe. Okay, I can say include equals all. Okay, let's see. You can see here the count is 20. 20 entries are there for all. Then unique is gender 2, and in courses 3. Top is Amit, male, gender, and AI is the top course. Frequency 1, gender, male is repeated 10 times, and the courses are repeated 8 times. Okay, frequency. Okay, you can interpret your data like this. Okay, wherever you see nan, because these are category name, gender, and all, right? So this will not be applicable for the analysis. If it is a numeric data, then you can do. And if you want to do all the numeric value summary only, okay, there is another way. You can write like this: age, comma, study hours, comma, marks. Describe. Here you have to add a square braces and you have to pick the uh, age, sorry, age, study hours, and marks, which are in numeric data. Okay. Something like this, you'll get a result. Same thing, whatever you're seeing there. If it is confusing, if you want just the only the numeric data to be summarized here with statistic descriptive statistics, then you can use the only the numeric fields. Okay, and same thing you can do the descriptive for categorical also for this data. Okay, value count. Okay, so value count, 1 minute, gender. Okay, so 8 times AI is repeated, and data science 7 times, cyber security 5. Okay, so you have to type separate guys. Sometimes it will not email. Okay, 10 male, 10 female. Okay, and this one I'll just take it to the next one in the next cell. I'll just run this and you can see. Okay, now I am doing a value count the courses that we have, right? Normalize is equal to true. When I do normalize is equal to true, it I mean it displays the data in percent. So 40% are in AI, okay, course, and 35 is for data science, and 25% is cyber security in the course section. Okay, this also you can use. Normalize is equal to true. These are all very important, guys. Okay. 1 minute. There is one more correlation. I'll just run this. Okay, df dot correlation, numeric only. Okay, so whatever the numeric fields we have columns in our data set, it will do the correlation. Okay, now you see here student ID, age, study hours, and marks. Okay, so these are all in numeric. Okay, now now if you see here, uh, age and student ID, there is no correlation. To student ID, everybody knows it is random, like a roll number 1 2 3 4. Okay, now what you have to do is you have to compare this. Okay, if you see 15.13.13, there is a correlation. Okay, age, study hours, and marks, there is a correlation. Okay, this one, age 1.76 and 0.76, there is slight this is 1, this is zero point 0.7, so there is a slight uh, uh, correlation difference you can see. Okay, study hours, okay, 741 and 95, so we can see there is a slight correlation between study hours and marks and age. Okay, same thing, this is how you're going to do the correlation data correlation. Okay, I'll run this last command. This I've already written, guys. Okay, so that it will not waste time. Okay, now you see it is again in the form of cap. Okay, You can see it is starting from 77 to 95. Okay. Now you see, so this is male. Okay. So this is here, this is here. Okay. Course enrollment. Data science is 7. AI is 7.5 or 8, and cybersecurity is 6. Okay. Now study hours versus marks. Okay. Do you see any correlation here? Study. Okay. So if you see 8, most of them are, if the course is AI, they are spending more hours. That is what I can inference here. 8 hours, amber sign means AI. Okay. This is how you're going to interpret with your data. Clear, guys? So this is another data set we did. Okay. I'm going to share this data before we close this session for the day. Okay, you can stop the recording. What is it called? EDA 08.